here. This is the today's questions. Let me read the questions for you first. Then we will go to the intuition part to implement the solution, to build the solution, and then I will implement the solution. Okay. So here it is the modern vertex. That is the difficulty is medium level. Okay. And what is the question saying? Question is saying a simple things that if you are given a directed graph, it means the edges between two nodes have the directions. It can be 1 to 0, like as you see in the diagram, or it can be 2 to 1. Like the directions is there. It is not undirected. Okay, that's why it is called directed graph. And there are nodes, the 0 to v minus 1. The nodes are labeled between 0 to v minus 1. And you have to find the mother vertex. So what is mother vertex? The mother vertex is such vertex that from that vertex we can go to every vertex. So for an example, the mother vertex of these questions, as you see in the diagram, is 0. So from 0 you can go to 2, from 0 you can go to 1, 0 to 2, 2 to 1. So you can go to 1 indirectly. You can go to 3 and 3 to 4. So you can go to 4 also. So it means in a gist that from a node you can go to every node directly, directly or via any path indirectly. That is called the mother path, mother node. Sorry, my mistake. So in the second test case, if you see that this is the graph, but if you see carefully that if you take that node one, from node one you can't go anywhere. Okay, so one can't be a mother node. From zero, can you go? From zero, can you go? From zero, you can go one, but from one you can't go two, or from zero you can't go two. So zero is also not a mother vertex. And from 2, the same picture as 0. You can go to 1, but from 2 to 0, there is no directed or undirected ways to go to 0. So that's why 2 is also not a mother vertex. So if there doesn't exist any mother vertex, so we have to return -1. That's why the output is -1. Okay. I hope this is clear. So let's focus to intuition part to develop the solution. So let me take the slide. So first of all, I would like to copy this. It's not copying here. Hmm, yeah, it's copied now. Then let me draw the diagram for you. Let me draw the graph for you. Okay, this is node one. And how many nodes are there? There are total 5 nodes. Or there are total 5 nodes. So I have to draw the 5 nodes here. Okay. Node one. I have to copy this. Node two. uh, don't go into the shape of the node. They are all identical shape. Okay. Total 4 node, and we need one more node. I also like to label it. Label as 0, label as 1, label as 2, label as 3, label as 4. And as in the source given in the diagram, that is 0 to 2. So there is connection between 0 to 2. So let me like to make a connections also. There is no connections. Can I make a line? Yes. I can. So from 0 to 2, there is a connections, and I would like to like as there is a directed graph, so I would like to like direct this graph arrow. Yes. So from 0 to 2, there is arrow. Okay. From 0 to 3, there is also an arrow. From there is also an arrow. There is also an arrow. 0 to 3. Okay. From 1 to 0, there is also an arrow. Also an arrow. Okay. From 2 to 1, there is arrow. Like there is edge. Let me draw it first, and later I will tell the solution. Okay. Uh, 1 to 1 to 1. Then it's 3 to 4. So that's the graph. I know that graph is a little bit different between the given graph, but the idea is same because the nodes positions are different. Okay, so don't go into it. Right? So let me select it for. I would like to zoom this. 嗯，there are two nodes. Minus one, three to four, three to four. So now the intuition is you can do a brute force approach. For the brute force approach, you can make a simple DFS function, and from each node you can make the DFS. You can make the DFS, and after the completion of the DFS for that node, you can check that all the nodes is visited or not. If all the nodes are visited, then the this node is the answer, and we can return the answer. Like here in the questions it is saying that we have to return the smallest node. We have to there is multiple what is this? Yes. If multiple such vertices exist, then we return one the smallest value. Okay. So we have to like let me write the pseudocode for you. Okay. Like this is very very easy. Then for I 0 to 0 to V, 0 to V, G is the number of vertices. We will make to DFS. In the DFS, we will start make the we will start our DFS from the that node from I0 to V. Let me make a bracket for understanding. Yes. So then we will pass a visited array, which is initially all the this all false value are there in the visited array, and we will pass the graph like which what will I will make. Okay. Later I will check if all value of the visited it will be a function. Okay, visited equal to 1, then it will be return this node as an answer. This is simply a pseudocode. I don't. I This is not a actual code. Okay, so just understand the intuition. But in this case, you all know the DFS will take big of in time because to travel all the nodes, it takes big of in time. Okay, but so we have to do our repeated task because multiple times we assume that we can visit the same array multiple same nodes multiple times. So how many times in the worst case you are visiting? You are visiting the worst case like v times, like number of nodes, and there are if v nodes are there, so you are like the inner loop is the outer loop is v, and the inner loop is also in the worst case will be v. So total time complexity will be like big of n square. Like the time complexity will be time complexity will be big of n square. So that is a case. That is the case. And if you carefully see that the constraint is so much tight here because 10 to the power 5 is there. So if we go into this, it goes to this solution, then the time complexity will be like approximate big of 10 to the power 10. That will give the theory for sure. Okay, so that's why I will first want to optimize the solution. Like I will do the DFS, we will do the DFS, but in the modified way. So let's see that how to approach that. First of all, to first of all to before going to the implementation part, I would like to understand you how I will develop the solutions. Okay, you will do the DFS. Okay, it is for sure, but in the modified way. So what is the modified way? So I will I will take a visitor array, like for every DFS we will do take a visitor array, and from the smallest node, like if there are 0 to 5, 0 to 4 node, from the smallest node we will do our DFS. Okay, from the smallest node we will do our DFS. And if like it is simple DFS function, let me write the DFS function for you here only. Um, Let me write the DFS function. So DFS in type uh, in visited uh, list adjacent. We will first make it. We'll first make it what? We'll first make it visited of I equal to 1. Okay, or you can give the true value. I am setting in 0 and 1, the integer. Okay. Later I will check for the neighbor, for integer neighbor adjacent dot get I. Let me write it in another slide because it is taking like multiple times I have to do the tab switching. Okay, so that's why I'm taking into another slide. Yes. So that is the point. For adjacent it means that all the neighbors. I'll check. I'll check. I'll check what? I'll check if visited of neighbor is not equal to not equal to 0. If visitor of neighbor is not equal to 0, then we will just make the DFS for that node. Okay. Then DFS neighbor uh, visited and adjacent. That is a simple BFS post. So according to the BFS, what will happen? Let's see in this test case. Let me first clear it. I don't need it. Okay. So if you make the tree, so first of all, what will happen? First of all, it will happen like yes. So first of all, it will go for 0, go for 0, go for 0. Then after going to 0, if we start from the 0, because I will always start from the smallest index, it will check what is the immediate neighbor. What is the immediate neighbor? 0. So 2, and I will also make a visitor array also. So let me draw a visitor array. Visitor array. And let me draw a table. Let me draw a table. table. So I need how many nodes there? There are 5 nodes. That's why I'm taking 5 nodes. Let me make it very much smaller. Yeah. So initially, if we start from the 0 node, it will be like 1, and it will check the immediate neighbor. There are how many immediate neighbor is there? That is 2 and 1. Assume we are going for 2. Okay. So we are going for 2. Then we will just copy it and paste it here. Then we will go for 2, and I will make the connections also. Okay. We'll go for 2, and the 2 will also be like visited as per the DFS. Then 2 will check what is its immediate neighbor. Its immediate neighbor is 1. That is not visited till now. So it will go for 1, go for like it will go for a 1. It will go for what? It will go for 1. Then 1 will check its immediate neighbor. Its immediate neighbor is what? 0 and 2. But if you can see, you can see easily that 0 and 2, and I have to check, I have to make the 1 here because this is the one second index, and now it is 1. But if you check 0 and 2, 0 and 2 is already visited, so it don't go there. So it's simply backtrack. It's simply backtrack. Okay, simply backtrack. After 2 will see, is there any others? 2 will see its immediate node, because its immediate node was 1, but 2 already favors 1. So 2 doesn't have any immediate node. And I am explaining you that just the DFS. Okay. So after that, it will check from 2 to 1. Okay. From 2 to, it will backtrack from 2 to 0. After backtracking, 0 is already traversed through 2, 0, 2. So 0 will check, is there others like the neighbors for that? So 0 will check, yes, there is the neighbor, there is the 3. So it will go for 3. It will go for 3. It will go for 3. Okay. So it will go for 3. Okay. Then it will check, is there any other node? And we have to make also 3 1. So it will check, is there any other node? Like if the 3 will say yes, there is another node, that is 4. So 3 will go for 4. 3 will go for 4. Okay. 3 will go for 4. Okay. Go for 4. And 4 will check, is there another? No. So 4 will simply backtrack. And 4, before backtracking, it will go simply do it 1. And 4 will simply backtrack, and it is also in backtrack because 3 is neither none. 3 is also no more. 3 is also no more. So it will that this is the DFS. Okay, this is the DFS, and you can see all the nodes, visited nodes is like all the visited array is already full, already visited. All the nodes are visited. When you start from the node 0, okay. Later, if we'll check so all the nodes are visited at 0, then this is the DFS. Let me write another code. So this is the DFS as I have seen it. So let me go to the main part, main intuition part. First, I'll write the code. Again, I will make you understand with the test cases. Okay. So what I will do, I will simply let me take another slide because the size will be smaller again. Okay. So I will just check for int I equal to 0, iv, I plus plus, I plus plus, I plus plus. Okay. What I will do? I will simply make if visited of I equal to 0, then I will call the DFS. DFS I, DFS I, V, I, yes, isn't it? Let me check there what all the parameters are visited. I visited parameter index. Okay. I visited adjacent. So adjacent is a graph. Okay. And another condition we have to do here. We are here to find that mother vertex, the smallest mother vertex. So for that, for checking the smallest mother vertex, we will take in mother, like that is the answer for our questions. We will initiate it with -1 because from the initial, for the initial there is no mother vertex. Okay, that's why I am initiating with -1. Then I will just update mother vertex with I. Why I will explain the test case. Okay, till then little bit patience is required. So then I will do visitor I equal to 0. Then DFS for I and mother vertex will be simply I. Okay. After that, and it will be continued after all the iterations. Like all the iterations is completed, I will simply make the whole visited array at false or 0. Why I will do that? There is conditions, there is reasons for that. I will also explain it. Okay. So before going to that, here I will write the code. Okay. Then I will explain. Then we will check, and then we'll simply make a DFS call. We'll simply make a DFS call. What will be the starting index? The mother vertex. Mother vertex. Visited and adjacent. Simple. Very much simple. Then I will check. Then I will check int I equal to 0, I, v, I plus plus. If there is still, if there is still any, if there is still any vertex which is not visited from the mother vertex, then we can say then it there doesn't exist any mother vertex. So return -1 there. Return -1. If this is not the case, then the mother vertex exists, and that will be the mother node which I have like got. So let me explain this whole code by an example, by the example. Okay, and you will see this examples holds this example explain this whole code properly. Okay, so I will simply like I will simply like let me take another slide. Okay. Can I copy it? Can I copy it? Okay, okay. I'll do this. Can I copy it? Let me check. Yes, it's copied because I need it. I need it very much. And I'll make it smaller in size. Okay, no problem. So, and I will also copy it because this is the DFS. This is the DFS. Okay, this is copied. This is copied. Okay, yeah. So, I start my work by the DFS from the as per the code from the zeroth node, and we had already seen the we had already seen the result that all the nodes are visited. Okay, so all the nodes are visited. All the nodes are, let me copy it also here because uh, forgot. Can we copy? It is copied. So from the zeroth node, if we traverse, if we make the DFS, and I have done shown the DFS whole DFS here, so it will cover whole the array. Then I will check for one because as per the code, I will check for one. If one is visited or not, then one also visited. Then I will check for four, and we will check all the nodes are visited. So we will instead we will get our mother vertices as zero. But I don't know, is it actually the mother vertices? So why I am saying that there is a reason, there is a reason. So what is the reason? I don't know. Is this a mother vertex? So now I have to make a DFS call from the zero to the mother vertex. And I will say that all the nodes are covered. All the nodes are visited again. So I will say, this yes, this is a mother vertex. But for the second test case, if you see the second test case on you see the second test case, let me copy it for there. Let me copy it for you. I don't want to like make. Uh, mhm. Then if you start from zero, then you will what? Then you will like from zero you will start and you will go to one. From zero you will go to one. You will go to one and let me right. You'll go to one, okay? And I have to also draw a table. What is the table? Yes, that is I have to add three. Okay, that's why I'm taking three. Yes, let me make it smaller. So initially, as I started from zero, then it will be one. And if we started from one, then it is also one. But till then, our I have covered like zero and one. But from can we go anywhere? No. From one, we can't go anywhere because from one there are no out degree nodes, out degree edges. Okay, like outside edges. So from one, we have to just backtrack. We have to just backtrack. Then I will again ask zero. From zero, can I go anywhere? Then zero will say I can also go to one, but I you have also already gone there, so you can't go anywhere. From zero, you will just like if you like here you call the DFS. Then from zero, you will just return. Okay. So now the mother vertex will be zero. Now the mother vertex will be zero. Then in the visited array, it will again check is the one node is visited. It will say yes, I am visited. Then it will again check. It will again check if the two parties are visited. Then the two will check. Two will say no, no, I am not visited. So it will again call the DFS. So for the DFS, it will again call the DFS. So two will again call a two will again call a like yes. Two will again call. But from two we say from me I can go to one, but one is already visited. Two will go. I can't go anywhere because I am restricted because one is already visited, so I can't go anywhere. So two will be also visited. But there is a catch. So what is the catch? So now the last mother vertex because last two was remaining, so the mother vertex will be two. Okay, if there exists a mother vertex, then 2 will obviously be the mother vertex because from 0 we can't go to every node. Okay, and 1 is already visited. So from 2 From two, from two, last remaining part was two. So this obviously we can go to sorry, my mistake. From zero we can go to one, but we can't go to two. So two will say that my immediate node is one, but one is already visited, so it can't go anywhere. So if we assume that there exists a mother matrix, so the two can be the mother matrix, neither zero and nor one be the mother matrix. Why? Because zero can't be mother matrix because from zero we have started the traversal, okay, and from zero we reached one. That's why one is visited. But so we can't reach two directly or indirectly. So from zero there is no way to go to two, and you will say so we can't check from one we can visit it to two or not. But think little bit. From zero you can go to one. Okay, if there exists any path from one to two, then it is very obvious that from zero also we can reach two, isn't it or not? So that's why from 1 we can't go to 2 also. That's why 0 and 1 can't be the mother node. If I don't know 2 is mother node is or not, but 2 can be a mother node. That's why I'm saying. So for that, we have to check either 2 is mother node is not, mother node or not. So for that, we will just clear the visited array and we'll clear the visited array. All the value are 0 now for now. All the values are 0 now. From two, we will again start our DFS. Sorry. Then from two, now from two, what is the immediate neighbor? That is one. Is one a visitor? Is one visited in the new visited array? No, it is non-visited. So it will go to one. It will go to one. It will go to one. Okay. But from one, it will go to one. Simple. Very much simple. And from one, it will ask itself that from me can I go to anywhere? Then one will say no, I can't go anywhere because there is no outside edges. Okay, outward edges. I can't go anywhere. So from one, it will just backtrack. It will just backtrack to two, and from two, it will check is there any other immediate node of myself. Then two will simply say to itself that no, there is no nodes. So it will complete its DFS. Then you will check the visited array. From the visited array, you can see you can't reach zero. You can't reach zero node from the mother vertex. So it is very obvious that the two can't be the mother vertex because there was a possibility that two can't be mother vertex. But from two now we can see we can't reach zero. So that's why two can't be the mother vertex. That's why there is no mother vertex. And that is for that is the answer is -1. Okay. I hope my whole understanding of the questions and whole intuition behind the questions I have made it very much clear. And if any doubt arises, then feel free to ask. I'll be happy to answer that. So let's dive into the coding part and code it accordingly. Okay. We have already done our DFS part. Sorry, let me copy it because this is the DFS function, and we have to change a little bit because that was a pseudocode, so there was something missing. So it will be simply just some time. Okay, I hope this is clear. It is clear. Uh, okay, tell me another. Yes. Before that, we have to make our array. We have to make a graph. Okay, so we will make a graph. List integer adjacent array list. So for int I equal to 0, id I plus plus adjacent dot add new array list, okay. After that, we will just take every edge, and as this is directed node, so we have to just put the edge from U to P, okay. So adjacent dot get U add the, sorry, there is no U and V, so we have the U is actually E of 0, the first node, and the V is actually the E of 1, okay, second node, okay. So the adjacent list is completed. Later I will do this part. Later I will do this part. Sorry. Yeah. Do this part. Uh, so let's move for that. We have to make an visited array int visited, and I will give the size as new int v. Okay. Okay. And for by default, the all the value is initiated with 0 only in Java. Okay? So that's why I don't have to fill it with 0. Okay. So mother minus I, okay. Till then this it is completed. Return after I will we just fix it. Then mother, okay. Um, so this is the code. Let me check if any error, like any syntax error is there, because I forgot to give semicolon there. So there is, I forgot to give semicolon also here. I forgot to give semicolon also here. Yes. I hope this should, it is right. This is, okay, this is not affected. I hope this is fine. Yes, fine. Okay, yes. What is going to, for each not applicable type, why this is not applicable? Okay, sorry. Because actually there is some mistake from int I equal to 0. I adjacent dot size. Am I forgetting something? Am I like doing some mistake? Yes, I'm doing some mistake because the list is there will be the nested list here. Okay, my mistake. My mistake. There will be nested list. Yes. So adjacent get adjacent at new at list and okay, new array list. Yes. So the other list. And integer element like neighbor, I will get the neighbor adjacent or decade I. Okay, let me compile it again. What is saying? Stack overflow. Okay. Why stack overflow? Sorry, this will be equal to equal to zero, not equal to zero. Because if not equal to zero, then it already visited. We don't go to there any websites. Yeah. Now that's it is fine. So now submit it. Yeah. So it's submitted successfully, as you can see. So this was the solutions and the intuition behind the questions. I hope this is clear, very much clear. So there is no by the way, there is no comments in my videos. I don't know am I going right or not. I right or wrong. So because I am very new in this field, like making videos and uploading it to the YouTube. I just do the coding from my first years, so I don't know about these things. So if any mistakes arises, like to deliver the content or to pitch the content, so I'll be happy if you give some feedback, so so that I can improve myself because I know there is very some error or some there is some mistakes from my side. I know that. That's why I have started uploading video to the YouTube so that I can reach to the people like the coding guys or the tech guys so that they can guide me like how to teach the content, what the understanding. I hope my solution is clear, but it is I don't know that it is like reaching the people in the perfect way or not. Is there any mistake or not? So please comment to this video if any feedback is there. Either it is good or bad. It is not mattered for me because I want just feedback because this is very much important for me. So if you like this video, then please like this video and subscribe my channel. This is not for the advertisement purpose, so that it will indicate simply that I am doing good. So I will give more effort to make the videos more informative. So that is my goal. I hope you like my video. If not, then also comment to me in the comment section. So for today, this is enough. So I will meet you in the next step with the new questions. And this is also my learning also because I am a student also. Okay. So till then, take care. Bye bye. And keep doing coding because coding is fun. Okay. Coding is fun. Take care. Bye bye.